So I introduce myself. My name is Zhenlei. I'm Android engineer in N26. It's one of the biggest fintech in Europe. And today, I will talk about a journey to server-driven UI. So first thing first, here's the agenda. I will divide it in 3 sections. The first part is the problem. I will show an example, a real example that I faced last year, and how the server-driven UI helped me to solve this problem. The second is I will explain what is server-driven UI. So everyone in this room will be on the same page. And last but not least, our journey to server-driven UI. And you can learn from us the great things that we have done, and at the same time, you can avoid some things that we didn't do so great. So a few months ago, more specifically, last year in November, we need to develop a feature. And the feature is the month of N. But first, it was not this name. It was the Black Friday. So as you might know, Black Friday is the end of November. But they want to change this feature to be the month of N. That means we need to ship in the beginning of November. So, and what consists this feature? We want to show some benefits to the users during the Black Friday, but they decide to be the whole month. So the benefit basically is we need to show this carousel with the benefits for the user, so the user can understand better which product that we can offer for these premium users. And then if you click in the arrow, we can go to this detail to see more benefits, more experience that the user can have. Cool. We need to implement this feature instead of in 1 month. We need to implement now in 2 days, because we need to catch up with the release cycle. And it's almost impossible to deliver a feature in 2 days. But if you see, it's not too much thing to do. It's just a carousel and 1 screen. But the time that you need to have alignment with the backend, to define the contract, define the test strategy, create a unit test, UI test, end-to-end test, you won't finish this in 2 days. If you will go to Go Horse, it's possible, but we don't ship things without proper tested. And so we managed to do this with the server-driven UI. And if you see, after we click this item, we can go to more screens like story. We just navigate to all the screens that we have. So we just need to build the month of and detail and the carousel. And if you see, the month of and detail screen is pretty similar to the other screens that we have, like the Explore, the Perks, and the Insurance. So we are building similar screen over and over again. So if you have an issue in 1 screen, most likely you have the same bug in the other screens. So you need to fix all of them, and this takes a lot of time to do it. Besides that, we need to build this screen in Android, iOS, and web, so across platforms. So the problem is multiplied by 3. So there must be a better way to do this. And the way was with server-driven UI to rescue. So first, I will explain what is not server-driven UI. As you can see in this screen, we have this Explore. And we have the first section, that's the insurance. And this is represented by this JSON object. So as you can see, there is a key in this JSON object, insurance, that represents this section. And we have for this card, the account detail, and also for the get more for 26, this carousel. So you can see a list of items. And if you want to build the highlights, for instance, the component below, we need to define the contract in the backend, define a JSON object, define the key, and in the front end, we need to get this key, identify what is the JSON object, and then we parse and convert to a UI, right? So we need to change the things in the front end. And this is called backend for front end, BFF. Cool. So what is server-driven UI? It's similar to BFF. The difference is we have the JSON object, we have a list of items. So as you can see, there is the premium insurance. You can see in the first item, the icon, the URL, the text, the premium insurance. But how will we identify that this part is specific for this kind of session, premium insurance? We don't care about the section. We care more about the component, the UI components. So the way that we identify this UI component is adding the type in the JSON object. And based on this type, we know what is the UI component that we want to render in the screen. If we change the order of this array, in the UI, you also change the order. So this is pretty cool. This is called polymorphic JSON. So here is a quick overview what is a server-driven UI. We have the polymorphic JSON here. In Android or iOS web, we map it to this DTO, header response, header data model. There are many names. I just wrote DTO just to fit in the slide. So it's the data model. Then with this DTO, we need to have like a render UI component that understands this DTO and map to our UI component. So here is the UI component. So why this is so cool? Because sometimes the product come to us and say, the insurance is not prominent for the users. So we want to make the insurance more prominent for the users in a way that we can move up. And in order to move this up in the screen, it's easy. We just need to change the array, the order of the array in the backend. And when we change it, they just switch the places. Cool. And then the product come again and say, yeah, it's better now, but still, we have more insurance that we want to show to the user. And in the carousel, just show the first three. We want to show more insurances. How we can do this? No problem. As you know, we have the type that's carousel. If we change the type of carousel to grid, and in the render UI component, we know how to render a grid, we just need to change the polymorphic JSON or change the backend to return the type grid. And then we have this grid here. Cool, right? So some benefits after building the system. The first one, improve the communication. Because we have already the content for the UI component. So the way to improve the communication is to have less communication, because all the communication has some noise. And we just have more communication when we need to build a new component. So we need to sit all together, define the contract, and define the components. Reuse existing UI components. As you can see, we want to use the grid, so we will change it from carousel to grid easily, because our render UI component know how to render a grid. So we just need to change the backend, and voila, we have the components in the mobile. Then we minimize repetition. We don't need to build the screen all over again. We just build one screen that supports this server-driven UI. And you can build many screens using only one component, only one render UI component. And if you have a bug, we just have a bug in only one place. And if you fix, we fix for all of the place that is using this UI component. We react fast to changes. As you can see, the product can come to us and want to change the order of the list. They want to change the UI components. If you will support already this UI component, we can just change in the backend super easily. We can launch without publishing on Play Store. This is, for me, is amazing because it takes time to release in the Play Store, to catch up the release cycle, to do some regression, so on. So now we just need to do some changes in the backend, perform the deploy, and then we have this already for all the users. Cool. Now I will explain our journey to server-driven UI. I will divide again in 3 parts. The first part is the foundation. How we build the server-driven UI. I will explain a little bit the code that we have, and also how we'll do the mapping and all the stuff that we have. I will show you soon. Then I will explain about the vaccine. What is this vaccine? It's an approach that we took to solve some problem related to cross-feature domain. What does this mean? When you want to build a component in another screen that you are not the owner. So if you work in a big team, this happens a lot of times. And this you might solve this issue. Last but not least, Androidless. How we will involve the server-driven UI in a way that they don't need me anymore as an Android developer. Cool. So first, the foundation. Before I start to talk about the foundation, you must have in place the system design or design system in your company. What is design system? There is this nice quote from Stephen High. We are not designing pages. We are designing system of components. So it's a complete set of standards to manage design at scale, using components and patterns. So there is this diagram that explains better. So for instance, you have the identity, you have the principles and the best practice. So that involves colors, font, image, the principles, that's the brand value, purpose, best practice, accessibility, training. So all those things create this component and pattern. That's for the design and dev. So you have the functional documentation, that how you can use those UI components, and then you have the technical documentation, how you use the code to use those components, right? So what we are doing, we are using this atomic design. I don't know if you have ever heard about this, but this was inspired by chemistry. So every matter is composed by atoms. So atoms is the small particle in the universe. So you can think about in the design. The small piece of design is the title, the text, or the color, and so on. So you have the atoms. And the combination of those atoms, you create the molecules. And the combination of molecules, you have the organism. And then they break the chemistry analogy because the main reason, because template and paste is used more for business. So you cannot say to your PM, hey, we are using this organism. It's better to say, we are using this template. So, but we went on to organism. So I have a better example here. So this is the atomic design that we have. We have the spot icon. That's this icon. We have the body text. And you have the small body text. The combination of them create this three-item container. This is the molecule that you can use all over the project. And then the combination of molecules and all the atoms, you can create this organism. That's the product spotlight. And as you might know, design system is not only design, but also code. So here, a small piece of code. Currently, we are not using Jetpack Compose. We are planning to use, but as I'm working in a Fish team, I cannot change everything to Jetpack Compose because there is a specific team that works in the core platform that's taking care about this. So for now, we are creating custom views. So we have this molecule to represent the information that we want to use in the custom view. We call view entity. And this view entity represents what is this molecule. So as you can see, there is the title, the subtitle, and the spot icon. And our custom view is super simple. We have this custom view. They need to implement this interface, bindable, that has the reference of the three-item container view entity, has the reference of view entity, that forces me to create this method, bind. And then I just need to call this method, and they know how to render this view entity, this UI. So if you see, it's pretty similar Jetpack Compose. So it will be easy to do this migration. So how was our foundation? First, we had like a kickoff. We had some decisions that we took. Some of them was good, some of them was not so good. So the first decision was, we want a stateless backend. What does this mean? The backend won't hold any state. So you just aggregate, then you get information from many microservices and provide the information for your screen. The next decision that was not good, backend without versioning. Why did they decide this? Because it's like MVP, we don't need versioning. You overcomplicate the backend. And this caused a lot of issues in the front end. We need to implement a lot of codes to handle versioning. So it's better to have the versioning in the backend in the first place. And we will just handle static screen. And this makes sense because in my team membership, we work close to market. Most of my screens are static. So it's perfect for server-driven UI. I just get the component, I just need to render the screen. And then all clickable components should have deep link and tracking. So this is super cool because if you will click somewhere, we just navigate to some screen. And this is be handled by the backend because they just provide a deep link for us. So let's explain the foundation. We have like 3 maps. The first map is how to map the polymorphic JSON to the DTO, then the DTO to the view entity, and then the view entity to the view. So this part of the presentation is the heaviest part because it's a lot about code. So, and we are before the lunch, so I know that everyone wants to go to lunch, but let's try to keep up here. So how you convert the polymorphic JSON to data model? We have 3 options of libraries: JSON, Moshi, and containerization. So Jackson is more used in the backend. Moshi is pretty common in the Android community and containerization. And we don't want to use Jackson because it's more used in the backend. A lot of Android developers doesn't know how to use it, so it's better to move to Moshi and containerization so more people can know more about those two libraries. But in the end, we decided to use Moshi. And the main reason that we decided to use Moshi is because as the backend doesn't support versioning, what we should do if the backend send some component that the frontend cannot render? You just crash, JSON pass error. So we don't want to have this error. We want to be more resilient in the front end. So we just ignore this specific JSON object that's failing. And with containerization, it's a little bit tricky. And with Moshi, it was pretty easy to do it because Moshi, they serialize the JSON as a stream. So I'm reading the JSON, and if there is some error, I just skip this JSON object and can still read in the next objects. So for this reason, we decided to use Moshi. So how was our Moshi setup? We create some new JSON adapter to have some fallbacks. Because imagine that we are support like some enum, for instance, outlined and none. And then suddenly we want to support another thing. And what happens with the new versions? You just crash because they cannot recognize this enum. So we just want to fall back to 1. So and then with Moshi, it's easy to create this adapter. And also we create a custom JSON adapter factory to handle this polymorphic JSON and ignore the invalid JSONs as well. So if you cannot recognize a specific type, we just ignore. So this is one example. We have this simple card with the icon, title, and subtitle, and we want to map this to this data model. As you can see, the icon is mandatory. What happens if the icon is optional? And the backend doesn't send. So as it's not optional, you just explode in the front end. So it would be really nice if we handle this case. And the way that we are handling is with Moshi, we manage to convert this object to an unknown DTO with the reason. And then we can track, and after tracking, we can tell to the backend, hey, we have this issue because you are sending this kind of components. And here, example that I mentioned, that we have tracking and the deep link. So all the things that's clickable, we have the deep link and also the tracker. So it's easy to know when the user clicking somewhere in the app. And we just need to map it to this operation object. Cool. And how we will register all those types in the Moshi? So we create like an enum that will have the information of the type, like the header, the body text, the button, the carousel, the section, and the grid. And then we just need to map this to the DTO. So we just need to write that, and then with this we can get those information and register in Moshi. Cool. Now, how we convert the data model to view entity? So usually what people usually do is just create like a mapper, and with this mapper, they see what is the type. If it's a header DTO, let's map to this view entity. And then you have a mapper for this. And then you have another map for the body text, and another map for the button DTO, and so on. And then you have like the mapper manager that you inject all those mappers. As you can see, you just expose this mapper manager, because if you have 20 UI components, view entities, you're gonna need to inject 20 view entities. So we did a different approach. We use polymorphism in this case. So I know that is a little bit weird, but the DTO to implement this interface item is a little bit weird, but it's not really, because a lot of people say, oh, DTO should be without logic. But in this case, it makes sense, because all DTO need to be converted to view entity. So we created just this interface item that forced me to implement this method, how to convert to view entity. And then it'll be easy. You have like a list of items, and just need to do .map, and inside it to view entity. Done. So you don't need to have the mapper, because the mapper is already in the DTO. So here's an example. We have the button DTO. We need to implement this interface item. So this forced me to implement a method called toViewEntity, because all DTO need to know how to map to view entity. And if you see, the button view entity is nullable. Why is it nullable? Because we don't have versioning in the backend. So what does this mean? If I cannot map to this object, I will just return null, and this object will be removed in the mapping later. But if you have a version in the backend don't need to send this object to a specific user. So there we get the operation that has the information of the deep link, and we just convert to this action entity, that's the deep link view entity, deep link entity. And if the user cannot understand this deep link, this is gonna return a null. So for this reason as well, the view entity is also nullable. And then we just need to create the view entity. Cool. Now we need to map view entity to view. So in order to do this, we create this view factory. What does this mean, this view factory? This view factory, they know how to create the view. And then we will need like a map of view entity to view factory to know how to create those views. And then we just need to register in the recycle view adapter. So here's the example. All the views need to have like a class inside. It's the view factory that know how to create the view. So we have this view factor that has the information of the view entity. Why we have this? Because the view factor need to know what is the view entity that will be used to create the view. And this is so nice because now, as you know, the view factor know about the view entity. So we can have like this map, as I mentioned, that we know how to map the view entity to view factory for the simple tile and also for the complex tile that you need to pass the map inside because the carousel, the section, and the grid need to know about this map to map to the other views inside, the children. But as the view factory knows about the view entity, we can use some really nice tool from Kotlin, some sugar syntax, that's the inline and the refired type. And why this is cool? Because with this, the function knows about this view entity. So we can just use this put and entity class so they know what is the view entity. And we just need to write the view factors. By that, the way that we saw before the map can be converted to this view factory map. You just need to call the register. So that means you don't need to write anymore the view entity because the factory knows about the view entity. Now you just need to register in a recycle view adapter. That basically we have the recycle view adapter, and then we need to pass as a parameter the view factory map. So this recycle view adapter is a custom recycle view adapter that uses the delegate pattern. So based on the view entity, they know how to render the view based on the type. Then we just need to have a method show content that we say recycle view adapter submit the view entities, and then they know how to show all the UI components in the list. Cool. How is the test strategy? So as you can see here, we have the microservice and polymorphic JSON. This part is pretty simple, contract test. You just validate if the JSON is valid. Then we need to map the JSON to data model to view entity, unit test. And the last part is screenshot test. Is with asterisk because I didn't implement it yet, but I'm start doing in Paparazzi. So we're gonna have a talk today in the same room, 2:30, talk about the Paparazzi. It's really nice because they run in the JVM, they run super fast, and it's really nice for tests, screenshot tests for custom views. Some tips about server-driven UI. The first one, please have versioning in the backend. It's super important. This will remove a lot of hassle in the front end. And all those logic that I add just because we don't have versioning. Create like a demo app with all the UI components so you can show to the design, the backend, to the other people as well, and also to products. Have some bootstrap scripts, for instance. Every time that I need to create a new component, it's always the same. I need to create a view entity, I need to create a DTO, I need to create a custom view, I need to create tests for that. My script take the JSON as an input and create all those classes for me. The only thing that they don't do is they just add a to-do. Here, you add the mapping. Here, you create the custom view. You can use some debug proxy like Charlie's or Proximate to intercept the request and change the response to another JSON. So you can build different screens and show those different screens to the product, to the design, to see how it look like before implementing in the backend. You can also use a mock web server as well, hard-coded. And we can have also A/B tests, because now everything is controlled by the backend. So that means the backend can change the order, can change the UI components, and then you can have A/B tests, because everything that's clickable has tracking. So we can also apply A/B tests. Another thing that we can do is the content management system. It's a CMS, so it's like a blog post that you can change the image, you can change the text, the title, and so on. Why this is nice? Because this is the person that is in charge to change those information is the marketing team. And in the membership, we work close to marketing. So before, what happened? The market come to us, say to the backend, hey, can you change the image? Hey, can you change the title? And then they need to stop their work to change those stuff. Now we connect to CMS or backend. So that means they can change it directly in the CMS. We will get this information, and you use the server-driven UI to show in the screen. So that means if the marketing team want to change the image, they just go to the CMS and change it, and you will reflect this in the mobile. Cool. Now the best part, vaccine. What is vaccine? As I mentioned, is to solve a cross-domain feature. So not so hypothetical situation. This screen is from the Spaces squad. My team is from membership. And in membership, we are responsible to try to promote user to be premium. So we saw this user has a lot of money. Why not make them premium? So we want to show this special card saying, yeah, you can be promoted to be premium and so on. So you have those kind of features. But we cannot go in this screen just add this component. So we need to align with the Spaces squad. And how is this situation? We have a PM that talks with the other PM. Hey, how long will it take for you to implement this kind of feature? They will just reply, I have no idea, because I need to talk with my team to see how long they will take to implement this. Cool. So they go back to their team. They talk with the team to see how long to give him a better estimation. But they devs also don't know so much about the requirements. So what happened? They went to talk with us about the requirement, because the business logic is in the membership, not in the space. So they talk to each other, and then the space dev talk with the PM and give estimation. And usually the estimation that the PM from space gave to us is not so good, because they have other priorities. So be really, 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 really nice if this part of the feature is owned by the membership squad. We have the full control. And how we can achieve this? So we created the vaccine. What is the vaccine? We have like a custom view. It's like our ads that you just add in somewhere, and they extend from a presenter, a view, this custom view. I will explain why they extend from a custom view, because extend from a view model is not so good, because it's a custom view. And this presenter is basically a way for us to perform a request to the backend to get all the information. If the request succeed, cool, we show the component. If the request fail, okay, keep it the same, we don't show. And how this is done, we have the view entity that I mentioned before. And this view entity has the information of the web service relative path, just to be safe. Because if you put the full path, somebody can intercept, change the path. So this is the relative path. And this relative path, they point to the membership microservice. So that means that you get the information from the membership microservice to show this UI component in the Spaces screen. So as you can see, we have a Spaces screen that is not server-driven UI, and then we can inject a custom view that's fully server-driven UI in this screen. Cool. And then we have Androidless. How will we involve the all server-driven UI? So again, not so hypothetical situation. To build a new screen, what usually we do? We create a new module, if you work with multi-module. Set up the DI. Then create the retrofit service. You set up the server-driven UI library, if you are using server-driven UI. Then you create the view model. Then create the activity of fragment. I don't know if you like more activity or fragment, but up to you. Then create tests. If you just want to cry every time that you need to create a new screen, right? So I start to think, what is the only thing that is different from those steps if you are built a server-driven UI? Create the retrofit service. It's the only thing that is different. because they use a different path, a different request. So why not create a deep link for this? So imagine that we create like a deep link that has a parameter, what is the path of the request? We pass this downstream from the view model until the retrofit service and set up the retrofit service. Then we can avoid all those boilerplate. So imagine that you have this deep link here, server-driven UI, and the path that's this web service that navigate to a screen that's server-driven UI, get this path, pass downstream until the retrofit, and perform the request. So this is an example. We have the month of end detail. We have this deep link. So when the user click in this button, they go to this screen. So we pass this API membership story downstream, and they will show this screen. And then we have another deep link here that when we click in this button, we navigate to another screen. That's also fully server-driven UI. Cool, right? What is this? A browser. So why this is so cool? Because we can now perform navigations without doing any change in the front end. And beside that, each screen that we have is also fully server-driven UI. So I don't have more work as an Android developer, so I start to work more in the back end. For this reason, life is too short to develop only for Android. And now, working a little bit more in the back end, I can try to solve all the issues that we have in the beginning regarding the versioning and the other stuffs. Thank you very much.